Before we get into this Bizgnus interview, we're asking for your subscription and for your feedback on this and all of our Bizgnus interviews that you'd like. Just scroll down and click on the subscribe button or leave your comments. Thanks.
This is the Biz News Podcast, one-on-one conversations with experts in business and personal development.
Be not afraid, at least of the coming metaverses that are being envisioned, so says Paul Powers, founder and CEO of the software maker PhysNa of Columbus, Ohio. His company has written programs that help find objects not by words, such as a database search might, but by their actual seeable characteristics, such as shape. In layman's terms, while very useful in a two-dimensional world, this could become the Google of the three-dimensional metaverse. Paul Powers joins us for this Bizgnus Interview podcast. Paul, let's start, if you don't mind, by telling our listeners and viewers a little bit about yourself and especially about your company, what it is that you do.
Happy to. Thanks for having me. So my name is Paul Powers. I grew up in the Midwest in Cincinnati and moved over to Europe at the age 16. I went over to study law, and I didn't do that because I wanted to be a lawyer, but because I actually wanted to be a startup entrepreneur ever since I was about 16, and decided that I was going to stop studying at the time astrophysics and go into a different direction. So I went to Europe, learned German, and lived there for 10 years, got a law degree from the University of Heidelberg. And then as soon as I passed it, the German bar, I basically threw that out the window and said, okay, now it's time to start a company. And I actually paid my way pay my way through college through having companies, but they were always, on my own dime for the most part, not a lot of investment. And I decided it was time to start something more serious. Luckily, it came to me from law school what that should be. It's funny, we created PhysNa off of a use case that we're not really pursuing, but the use case that I had for it was intellectual property theft. There are all these algorithms that'll find plagiarism, right? If you steal somebody's logo, music video, that's something that they've written. But as soon as you get into a three-dimensional world, which is one that we live in, and somebody's stolen your engine design or a component or whatever, all of a sudden there's no way of matching them and seeing they're related to each other. And so people spend fortunes on patent analysis, and people write these huge, very, very lengthy descriptions of what these things look like and how they operate and how they're measured and how one thing might be different than the other. And in my mind, that was just silly. There's software that does that. All you have to do is match these things, and you should be able to do that automatically. Looked in the market. There were tools that said they did geometric search, tried them out. They were awful. They definitely wouldn't work at scale. They were always on-prem. They were based off of pictures. So essentially, I'm oversimplifying a little bit, but they were only able to match part to part. So the only way you'd be able to find a patent infringement would be, okay, I designed Mickey Mouse, and somebody copy pastes it and creates and uses that exact model or something very similar. Otherwise, they wouldn't find it. And even then, if it's a different file format, sometimes it wouldn't find it. So realized we started a company to fix that. And the burden is pretty high because you have to not just match things that are identical, like Mickey Mouse to Mickey Mouse. If I put Mickey Mouse ears on something or Mickey Mouse eyes on something, I need to know that that's still Mickey Mouse. It's still an infringement, right? So we set out to create a different way of analyzing models, and the brief time in astrophysics gave me an idea for how to do that. And essentially, we have this patented approach that we use, a series of algorithms and some machine learning, and it allows us to codify what's physical. And so PhysNa is short for physical DNA. And just like with DNA in the biological sense, PhysNa can show how all physical items, in the sense of 3D models, are related. An example would be if I were to find a bolt laying around and search for it in PhysNa, it would show me everywhere in the world that bolt was used, or everywhere it was used and everywhere it could be used, even if it was a different bolt being used, but that bolt's the same thing or functionally equivalent. It would show me where it could be used and how much of it would actually fit. Maybe the bolt isn't long enough for the hole, but it fits into it. And then it'll show me this doesn't fit all the way, but if you just need half of it to be filled, it'll fit there. When we developed that, we found very quickly that going after the patent use case was, even though we can, it was going to be very expensive, because at the time we didn't have enough money to index everything under the sun. And so we were bombarded with use cases, and we decided, one of the most valuable, it seems like the common thread amongst all these use cases that we were approached with was that we always had to talk to the engineering team at a company first, because they were the only ones that understood 3D models. They were the ones that dealt with 3D models, and everybody else in the company was sort of oblivious to it. And so we decided, let's build a tool that speaks to them first, and then PhysNa can be used for other things. So what we do for engineers is we take the models and we make it like code. A good example would be if I were to take using this analogy, if I were to take the first paragraph out of Little Red Riding Hood or some book and search for it in Google, no one would be surprised that the book would show up. And if I were to take half of a sentence out of that paragraph and search for it, no one would be surprised that, yeah, the book would show up, and so would other books and other literature that contain that half sentence as is. But as soon as you do that with geometry, people are blown away. They don't understand how that works, right? If I can take a bit of a model and I can find everything that contains that and how it can go together, that people don't understand how that's possible. It's possible because we've turned that model into code. So as far as the computer is concerned, you're almost doing the same thing, right? I can show you exactly where things are located and how they relate. And what that means is that we can make people reuse designs more often. So for an engineer, they have the ability to essentially copy paste. They can reuse things. They have we're coming out with something now that's almost like autofill. As they design, it literally will try to do the rest of the work for them based on what's been designed in the past. These are things that are common in text. You'll notice autofill in Google search, but as soon as you go into 3D, it's unheard of. And so studies show that engineers and 3D designers, people who work in 3D and work in hardware creation, they are 1/5 as productive as people who work in either coding or who compose text, right? Because they have reuse, they have search. And so we're overcoming that. Then we're doing that with 2 products. So there's PhysNa, which is the enterprise tool, and then we have Thangs. Thangs.com is actually totally free. It's a consumer tool. And that is now the Google that we were missing in the beginning of this company, right? So it crawls the web, it indexes models from all public sources, has over 13.5 million models on it now. And if you upload, you can of course search by text, but if you were to upload a model, it'll show you all the models it found publicly that are either identical, similar, or contain that model or are located within that model that you uploaded. And it won't show you all the analysis of it like PhysNa, like the professional version will, but it does that for free, right? And so it has, in addition to having that search engine, has a tool on it that will show you differences between versions of parts, so which we call Thangs Workspace. And so the idea with Thangs was to create a free version of a GitHub plus Google combo to overcome that problem that engineers and 3D designers have. Because at the end of the day, all innovation requires hardware. Even software innovation is relying on it. And if we're only going at 1/5 the rate that we should, that's a problem. So that's the main use case.
Google, for its maps, has sent cars up and down every street, byway, highway on the planet, it seems, with cameras attached to them because they physically they want to see the street view. Do you have to have the model, the actual object in front of a camera before you can use it?
So we look for models that are already created, right? So the way that those models are created, there's a number of ways. One, obviously, they can be designed, whether it's in CAD or it's an animation tool of some sort. 2, the model can be scanned, right? So and there's many ways of scanning. You can scan it with LiDAR. You can scan it with photogrammetry. Any smartphone can do a 3D scan these days, right? So however the model gets into a 3D format, we can ingest it.
That sounds in almost science fiction-y. But where do you expect this to go in 5 or 10 years? Where will you be there? You won't be looking at screws for machines or anything like that, will you?
Oh, I think that we'll always have that functionality there because people will always need screws for machines. But it'll also contain a lot more. 3D is, 3D is a really core piece of technology only because it's a representation of the real world, right? And a lot of people view 3D as, a gimmick or an element of technology like 3D printing, or, there used to be these 3D movies, whatever, that didn't really go anywhere. But in reality, what everyone's been searching for is a way to make technology more immersive. Technology is there, software is there to make our lives easier, the power enhancers. And so far, it's been doing that in a flat interface that has nothing to do with the real world around us. When you bridge that gap, and software can interact with your real world and be immersive and give you insights into things that are more natural for you to consume, it becomes infinitely more powerful. It's kind of like when it went from 1D to 2D, Morse code to binary. All of a sudden, we went from having telegraphs sent around the world to having smartphones and all these apps. When you go from 2D to 3D, you'll see the same thing. We're seeing the beginning of that. And that's why Mark Zuckerberg saw it as well. He said, they changed the whole company into Meta, they're creating the metaverse. And by the way, there's not one metaverse. Many companies are building out their own 3D environments. And it's going to be like the web, right? So if you look at AR and VR, augmented reality, virtual reality, mixed reality, it was a $30 billion market in 2021. And forecasts say that it should be about a $300 billion market by 2024, about 10x in 3 years. And that's going to continue because technology is going to plateau if we only stay on a flat interface the rest of our lives. It has to become immersive. And as it does, that problem that I mentioned about not being able to find parts, not being able to reuse things, not having machine learning working on 3D models at the full capability that you would have with text, those limitations are only slowing down innovation. And so what we'll see happen in the next few years is that PhysNa and Thangs is the primary branding that we're going to be moving forward with in the future, will become not only more mainstream as a product for the engineers and for procurement and part identification, but you'll also see it powering a lot of other tools. We already have companies now that are using PhysNa via an API to power something else. And sometimes it has nothing to do with 3D. You take a picture of something and we tell you exactly what that part is and everything about it. And they're like, how'd you do that? Well, because 3D data in the background told us. We were able to find exactly what part that was because we matched it off of 3-dimensional inputs versus 2D. But all you saw was a picture and a whole bunch of information come out. And in the case of an API app that one of our customers has. So that's where I think we're going to see things moving forward.
Let's talk just a tad about the metaverse or these metaverse, whatever the plural of metaverse might be. Where do you see that in 5-10 years? Are we going to be living in essentially a cartoon avatar world or not?
I think that we're going to see it. It'll be similar to the progression that we've had with flat interfaces in a sense, right? You'll have some capabilities that'll be fully immersive and some that are semi-immersive. And so you have virtual reality where the difference between virtual and augmented is whether you're seeing through glass or not. I'm oversimplifying, but if you're talking about the headset, that's the main difference. And virtual reality is amazing for watching a movie. I played someone recommended this game to me. I wanted to play for 5 minutes. It was this horror game called Phasmophobia, and you're a ghost hunter in a house. And I'm not afraid of these things. I can watch any horror movie without really spooking. I could only make it 5 minutes in that game. It was terrifying. It was just so immersive, and that's great for VR. AR is different. AR is more interactive with the world around you, right? So there are games, if you have a HoloLens, where it's not just for games. Actually, AR is very, very pragmatic, and so is VR. But if you had a game, it would be like maybe you're shooting aliens that are coming out of walls, but they're your walls in your house. They're jumping off your sofa and stuff like that. And this actually exists. These games exist. But more practically, as these things become more mainstream, not only are they starting to become more mainstream in enterprises for repairmen and mechanics, et cetera, but they'll also become mainstream for the average user once the battery life is long enough and the cost is low enough. And you'll start seeing people use them in lieu of having a smartphone at some point, or it'll be the main interface and the smartphone is just the power behind it, maybe in the near future. So I think that you'll have the option to choose. Do you want to immerse yourself in an alternate reality, or do you want to enhance the current reality that you have? Or just know more about what's around you. Maybe you don't change anything. You just want to understand it better. And all those options will be available to you.
Paul, you probably have thought about how this will affect society. Give us your views on that.
I think that I think it'll be a very positive thing, to be honest with you. I definitely do. A lot of people look at these things and they freak out because they think, okay, that almost sounds like if you take a virtual reality far enough, you can start to imagine a matrix, right? And then they think of the movie The Matrix and how that was used for dystopian purposes. And then they think about, Terminator when they see AR, and they think about the worst possible outcome. But people did the same thing with the internet. They did the same thing with computers, and it's true. It's a power enhancer, right? So anytime you have more technology, if you're a good person, you can do more good. If you're a bad person, you can do more bad. That's the simple way to look at it. But overall, society tends to be more good, and people tend to do more good with technology. So having something that augments the human experience is more of a net positive than a net negative, in my opinion. And what it'll do is it'll have very real implications for people's efficacy, right? If you can wear augmented reality glasses, for instance, what if you're a firefighter and you have a hard time seeing through the smoke and identifying where people are located, but there's an application on your headset that can use LiDAR that can maybe pick up on something that's hard for you to, or whatever, because there's no lighting or whatever. That is something that could save a life, right? So I think overall it's going to be it's net positive. And I think that what's really cool about it is that it allows people, this 3D future, it allows people to do more, right? And I think that one of the most depressing facts about human history is that most people never got to deliver on their potential. They died from some kind of disease early on. They were born in a very poor environment, whatever it was, but they never got to give back to society or add to society. This technology means that there are fewer steps between your brain and your ability to create and sharing that with the world. If you can innovate at the speed of your imagination, if you can alter things at the speed of your thoughts, then you can unleash the full potential that you have versus 1 millionth of it, for instance. And that's what excites me about it.
It sounds like it's going to be a very exciting world, but I worry about the bad guys trying to control it, I guess. Would you take a moment to tell our listeners and viewers where they can get more information about you and your company?
Sure. So if you look on LinkedIn, if you look up PhysNa, PhysNa, you'll find the company. Increasingly, you'll find more and more information about Thangs, which is just Thangs with an A, Thangs. If you want to try this out, you can go to thangs.com. It's free, and play around with this. Even if you're not a 3D designer or user, you'll understand the software right away. And if you want to reach out to me, I can be reached over LinkedIn. I think that the future is going to be really exciting. I would encourage people to be proactive versus reactive when it comes to thinking about these technologies and their adoption, because we're at the precipice of a new era, kind of like with the internet, and people who can foresee that, and then they can imagine that what'll come next, and they can act on it now, they'll have a massive advantage over people who just wait to be the last adopter of whatever comes out. And so if you're interested in technology, if you're interested in business or startups, then I would say really take a close look at this emerging world of 3D. There are many aspects to it, and I think you'll find that you have a very big role to play on the future of our technology.
You've been watching the Biz News Podcast. We welcome your input. Send your email to editor@biznews.com. Thanks for watching.